Welcome to another video in the series of the Steinberg Systems SBS-WS-500 weather station. Today we will take a closer look on how we can harvest the data produced by the weather station. Welcome to the video. The content of this video will be separated in three parts. We will take a brief look at the weather station itself. If you want to have a more detailed introduction to the weather station, there is an unboxing video. I will link the video in the description of this video. After the introduction, we will take a closer look how we can configure the weather station to send the weather data to a local server. When we have done that, we will go to the next step, and that is to process the published data in a Spring Boot application on our local server, which was configured here in this second step. The weather station is a feature-rich 8-in-1 sensor weather station. It measures a lot of different weather data. You have temperatures, you have humidity, there is rainfall measurements, wind speed, and atmospheric pressure. The weather station is also Wi-Fi enabled, and that means that all the measured data can be transmitted to different weather cloud services. The supported weather cloud services are the ones listed here. There is the Ecovit weather service on this URL. There is also support for the Weather Underground, this URL, and there is also support for the Weather Cloud service and also the Weather Observation website service. And as said, there is also support for a custom service, and that's the last hosting service here. We will take a closer look at this functionality today in this video. And now let's see how to configure our weather station to connect to server. We are starting by clicking the configuration button here. And then we see a setup menu, and we have to go either up or down with the keys here. And then now we are below there, and we have to go to the weather server setup. And when that's selected, we click once more on the plus button here on the left. And then we are presented with another menu, another setup menu. And then we go one step up, and then we arrive at the customized option, and then we click on the plus button another time. And now we are at the configurations for a customized server. And we are presented with a couple of options, and that's the state, if you want to have this functionality enabled or not. When it's in the enable state, as here, then data will be sent out to the configured server. And the protocol type, you can select a couple of protocols. In this example, we will use the EchoWidth protocol, so we leave it like that. And then the next section is where you can configure your IP address or hostname. In this case, I use a local IP address, which is reachable inside my home network. And to configure that one, you click the plus button once more, and then you will have to navigate here with the left and right arrows, and then you select your input with the enter button, and then you do that until you have entered all your data. If you have done something wrong in the input, you can go to backspace and click enter, and then it's gone again. It's a little bit tedious because you have to use the left and right and up and down arrows a lot, and then you have to switch potentially to not only this keyboard, virtual keyboard, but to other keyboards as well here, if you have special characters or something like that. But you will only do this once. And when you're happy with your input, you go to return again, and then you do one step below, and then you have to input your destination port on the IP address where you are expecting the data to be sent. And in my case, it's the 8082 port. And oops, sorry, another one. And then the next entry is how often do you like to have the data sent to a server? And I have configured 59 seconds. That means every 59 seconds should there be a data package sent to the local server from the weather station. The last configuration parameter is on what path do you like to have the data sent. This is then the entire combination will then be your IP host name, and then you have the port, and then you will have the path. That's the entire URL which will be used by the weather station. And this path is something that you have to define yourself, and the entered path here is the one which my local server will expose. That's everything you have to do to configure a local custom server to receive data from the weather station. Okay, now what the weather station can do. It can transmit data over Wi-Fi. We have configured our weather station to publish the collected data to a local server. And now the last step is to see how we can process the sent data in a Spring Boot application. Okay, let's see some code. As said, we will use Spring Boot application. That's a Java-based application which we will write today. and it's running on the Spring Boot platform, which has an embedded web server, and we will take use of that one today. The project, this is part of a larger project which I'm running, and I have named it the Solar Weather Backend application. It's a standard Maven project with the normal Maven structure with source, main, test, and main Java and resources. And now we will take a closer look on what we need to do to be able to harvest the sent data from the weather station and do something with it. We have the main class of the application. That's the standard Spring Boot application main class, and that's bootstraps the application, and the application is very small. It consists only of 2 more classes, and we will take a look at the weather station controller class, because that's where all the magic happens. This is a REST controller class. It's a normal Java class which is annotated with the REST controller annotation. The REST controller, das ist ein Spring Framework annotation, and that enables this class to act as a REST API to the outside world. We define request mapping on this class level, and as we have seen in the configuration part of this video of the weather station, we entered a path in the weather station which starts with API/v1/, and that's the base path of this REST controller. This REST controller has at the moment only one public method. It's named create weather station data entry. That's not very important, the name here of this method, but what's really important is this post mapping and the values. This annotation here, that's also a Spring mapping, and that defines that this method is an HTTP post mapping method, and the value here is or in other words, it defines the URL on which this application will respond to. That means this part here, in combination with the base path from here, those two concatenated makes up the entire path to this method. And as we can remember, the complete URL in the weather station consists of this path, this entire path here above, and this path here. So that means when this application is running in a local server and the weather station is posting the data according to the configuration, this method will be called, and the input parameters to this method, that's the content of the post HTTP message which is sent from the weather station. That's in the Java world, it's a multi-value map, and it consists of key values, as a map normally is, and the key in this case is string based, and the values are also string based, but the value is a list. So the second argument here, or the type argument, is a list of strings. This consumes part of the post mapping annotation, defines which media type this method consumes, and the weather station sends the requests with the application /x www form URL encoded and coding. Okay, that's the header of this method, the signature, and then it's the question, what do we do with these values here? You can do whatever you want, because this is the entry point here, and with this signature, the data from the weather station will end up here. For this example today, I have decided to create a Java object which I call weather station data entry. This entry consists of a lot of properties, and those properties are exactly those properties or information which are sent in the HTTP post message from the weather station. For instance, there is the information date UTC, that is date and time for the message, the temperature in Fahrenheit, the humidity, the atmospheric pressure, relative and absolute, and so on. There are a lot of values here which are sent from the weather station, which all can be harvested. Let's go back. I have built a utility method here to create such kind of object with this input which we receives here. And just let's take a brief look at this method. It's a normal Java method, nothing fancy. I become my parameter map as input, the multi-value map, and since I want all of the properties of the input, I have done mapping for each property here in the input into the desired destination in my Java object. It's a simple one-to-one mapping with a little bit of error handling, but not much. There is the parsing method here becomes the parameter map as input and the key, which is decided to get the value for. And as we see, the parameter mapped as a normal Java map, and with the get method and the key, you get the value for this key from the map. And as we already have seen, the value is a list of strings. And I do here a null check. That means if the string list is null, there is no content in the map for this key. And the keys are, as we have seen, those static members here, and they are all here above, and they are defining the keys which are sent in the payload from the weather station. If there for some reason is a key missing in the parameter map, then there will be an error message, and then I return an empty string. That might resolve in an error in a later step, but that's the way I have decided to do the error handling at the moment. If there is a value for this key, I will get the first value because there are no multi-value keys in the payload. There is only a one-to-one mapping, key and value, and thereby I can always take the first entry in this list of strings. And it might also be that the value is null, and then I again put out an error message in the log, and then I return an empty string. That's more or less everything I do in this method. And if there is an exception thrown in the parsing here above, then I make another log statement and then throws the exception to be handled later on in the code. And that would be here. And then the strategy at the moment is to write another log message, error log message, that the input could not be parsed into a Java object. And in this case, I have decided if the input is not parsable or not complete or produces an error exception in the code, then I ignore this input and responds with an HTTP status created anyway. The reason for that is that the weather station cannot respond to any error messages. It sends the data it has, and if due to an update or something like that, the format of this input is not the same anymore, then this code has to be adapted. What else do we have? Not much more. Maybe we can take a short look in this Swagger configuration. That's a way to visualize and test the API, which is defined in this REST controller class. Let's start the application and see what's happening. Java will compile the classes at first. Then it takes a couple of seconds to start the application. As we can see, the application is starting as a Spring Boot application. It's with the version 3.4.2, and now it's running, and we can see that the application is running on the port 8082, and we can take a look at the Swagger UI. To see what it looks like. I make another refresh to ensure that it works. And this is now the Swagger UI. That's what we become when we define this configuration in the application. And as we can see, we have called the localhost and port 8082. And here we have our post method with exactly the path which is defined in the REST controller class. That's all for the Spring Boot application. And let's build the production code as well, and then we will deploy the built artifact on our local server, and then we will see what it looks like live. I have opened the Maven window, and then I have selected clean install on my Solar Weather backend project, and then we do a simple run Maven build. And now Maven will create the production bundle for us. It's generating a complete Spring Boot application jar, and that's a runnable jar, which means that everything is embedded which is needed to start the application, including an application server. Now it's finished, and we will find the built char here in the target directory, and it will be this one. I copy the file, and then we go to the local server to deploy to deploy this file. And this is my server, my local server. I have a directory here on the server where I have deployed my applications, and now let's copy the created artifact. Takes a couple of seconds. And there it is. It's an executable jar file. The size is quite large, 25 megabytes, but it's everything included, which is needed to run and start application. And to start the application, I have written a PowerShell script, and let's start it and see what's happening. It starts in a shell, and as we can see, the application is starting analog to what we have seen inside IntelliJ. It says that it's Spring Boot 342, and the application is starting. It's also running on the port 8082, and it took almost 5 seconds to start, and we can already see the first couple of entries from the weather station. As we can remember, I did only put it the input from the weather station, which has been parsed into a Java object. This one I did write it to the application log, but also to the console log, which we can see here. And the content is as follows. That's the date UTC, that's the date and time from now, and we receive all the values for each property on a separate row. And we will receive one entry per minute because I have configured it like that in the weather station. I think that's all for now. It's quite easy to harvest your weather data if you have a basic knowledge of Java and Spring Boot applications. Thank you, and I see you the next time.